Hello viewers, welcome to K Diagnostics. Dio here. Today we have a 2015 Honda Civic with a 1.8 liter. The customer complaint on this vehicle is the check engine light remains on when the engine is running. So the first thing we're gonna do is we're gonna go inside the vehicle and confirm the customer's complaint. After confirming the complaint, we're gonna connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. After we retrieve the trouble codes, then we will talk about what directions we're gonna go so we can fix whatever that's causing the check engine light to remain on when the engine is running. So now let's go inside the vehicle and confirm the customer's complaint. So I'm gonna start the engine so we can confirm the customer's complaint. So right there, as you can hear, the engine is running. But interestingly enough, the check engine light did not stay on, which is weird because I was told that the check engine light is remaining on when the engine is running. So the customer also stated that the check engine light comes on and off. So now what I'm gonna do is I'm gonna turn off the engine. I'm gonna get a scan tool connected to the vehicle, and then I'll bring you guys back up so we can scan the engine control unit. Hopefully we have some pending codes in the engine computer. So now I'm gonna turn off the engine. Let's turn the key back on. I'm gonna get a scan tool connected, and then I'll bring you guys back up. Alright, so I got the scan tool connected to the vehicle. So let's scan the engine module, and hopefully we have some pending codes here. So the scan tool is done scanning all the control units on the vehicle. So right here on the engine computer, we have 3 trouble codes. The first one is P0171 fuel system 2 lean, and the second one is P0138 O2 sensor 2 circuit high voltage. And then the third one is P0139 oxygen sensor 2 slow response. So these are the trouble codes that are causing the check engine light to come on. What's interesting is that the check engine light is not on right now, but we have these 3 trouble codes. So I'm pretty sure these trouble codes are pending right now. Okay. It's weird how it says permanent codes. I mean, they are permanent right now, but for some reason, the check engine light is not on. So once we fix these 3 trouble codes, the check engine light will not come back on. Okay? So before we focus on these 3 trouble codes, let's scroll down and see what are the trouble codes we have in the other control units. So we got nothing in the transmission control unit. We have 3 trouble codes in the ABS control unit. We got 1 in the tire pressure control unit, and 1 in the electric power steering control unit. Let's keep scrolling. And we have the same codes over here on the generic side of the tool, P0171 and P0138. O2 sensor circuit high voltage bank 1 sensor 2, and the other one is P0139 O2 sensor circuit slow response bank 1 sensor 2. So these 2 trouble codes over here tell me that we most likely have 2 problems right now. The first problem is a lean condition. So this engine is running with more air than it's supposed to. And we also have an oxygen sensor that's lazy. Okay, we have an oxygen sensor that's responding slowly. Okay, and this can be caused, mostly this is caused by a defective sensor. So it sounds like the signal of the sensor is sticking high. Okay, the sensor is not reacting to the oxygen content inside the exhaust stream as fast as it should. Okay, that's what causes this trouble code to be set. You might wonder if this trouble code is also causing this P0171 trouble code to be set. I've seen bad O2 sensors cause lean trouble codes, but I don't think in this case we have this code over here causing this first trouble code to be set, because since the description of this code over here says that the circuit, okay, the voltage on this O2 sensor circuit is high, usually when you have a bad O2 sensor causing a lean code based on this high voltage over here on this signal wire of the O2 sensor, we should have a rich trouble code, okay? Instead of having a lean trouble code, we should have a rich trouble code because of the high voltage that this O2 sensor is putting out. So since we have a high voltage on this O2 sensor and we have a lean code, so this tells me we most likely have two problems. So now what I'm gonna do is I'm gonna go into the engine computer and I wanna graph the O2 sensors. This is a 4-cylinder engine. It has two O2 sensors. We're gonna graph both of them, the upstream O2 sensor and the downstream O2 sensor. And we're also gonna look at our fuel trim numbers, okay? To see if we have a air leak somewhere or if we have a fuel starvation problem, okay? Because these lean codes are usually caused by a vacuum leak or a dirty mass airflow sensor. So now let's go into the engine computer. So we're gonna go to data. So we're gonna go to powertrain data. So I just wanna look at the O2 sensor data PIDs. So it looks like we don't have our O2 sensor data PIDs in this data group. So we have to back out and let's go to emissions data. So we have a bunch of data PIDs. So we're gonna customize this list. I just wanna look at the data PIDs that are relevant to what we are doing. So let's deselect this. So we're gonna select the emissions data. Let's list this. Wow, this is weird. I don't know why it's not letting me just select a couple of data. So what I'm gonna do is instead of using the OE side of the scan tool, let's go to the generic side, okay? So let's go to the OBD direct. I think over here we should be able to customize this data. So let's look at our freeze frame data first. I want to see what the computer was looking at when this trouble code was set. So we have freeze frame for this P0171 trouble code, system 2 lean bank 1. So when this trouble code set, our engine speed was 1275. Okay. Our engine temperature over here was 159 degrees Fahrenheit. And we were in closed loop. Our short-term fuel trim numbers, wow, short-term was at 43.8%, and then long-term was at 32.8%. Wow, so this vehicle is running lean, okay? It's running with more air, and the computer is trying to compensate for that excess air. So we need to figure out where this air leak is. So now let's back out. So we can look at the trouble codes again, just to double check. So we have the same trouble codes here. So now let's go to data display. So we're gonna click on display current data. So we're gonna customize this list. We're gonna grab our engine speed. We're gonna grab our fuel status. We're gonna grab our mass airflow sensor grams per second data PID, our engine temperature, our fuel trim, okay, short term and long term, our O2 sensor data PIDs. All right, so that's all I want to look at. So we're gonna list these data, and I'm gonna graph our O2 sensor data PIDs. Remember, we have a code for this second O2 sensor, and it said that this O2 sensor is responding slowly and the signal is also sticking high. Okay, now I'm gonna start the engine. So right off the bat, our long-term percentage is 28.1, which is a lot. Okay, so now what I'm gonna do is I'm gonna start the engine. We're gonna watch these numbers at idle first. Okay, on a good engine, the correct percentage on the fuel trim numbers, I mean short-term plus long-term, should be plus or minus 10%. Okay, anything above 10% is concerning. So this number we have here is already high, so we have an engine that's running lean, and we need to figure out why. So now I'm gonna start the engine, and then we're gonna watch these numbers. We are still in open loop. I'm gonna give it gas. So right there, we are in closed loop. So let's watch our second O2 sensor there. And let's watch our short-term fuel trim numbers. So we have about 17% on the short term, which is a lot. So 18% and 28% on the long term. Okay, so you can add these two together. We are way over 10%. So we have a problem, guys. And when you see numbers over here without a minus sign in front of the numbers, this means we have positive numbers over here. Okay, so these are positive numbers, which mean the computer is actually adding fuel in the cylinders. So the injector pulse is being increased. So the injectors are being turned on longer to compensate for that excess air. Okay, and high positive fuel trim numbers can be caused by a defective mass airflow sensor. Okay, if you have a dirty mass airflow sensor, it can cause high positive numbers, or a vacuum leak, okay, in the intake, or clogged injectors, or a defective fuel pump can also cause high positive numbers. Okay, so now what I'm gonna do is I'm gonna increase the engine RPMs. If these numbers get better when I increase the engine RPMs, that will tell me that our fuel delivery is most likely good, and our problem will most likely be a dirty mass airflow sensor or a vacuum leak. Okay, so basically the rule of thumb is worse fuel trim numbers at idle, and if they get better at a higher RPM, the problem usually ends up being a vacuum leak or a dirty mass airflow sensor. So now I'm going to increase the engine RPMs, and let's watch these numbers. And as you can see right now at idle, we have 21% on the short term and 28% on the long term. Okay, and this O2 sensor over here is oscillating a lot, which I don't like, because I mean this can be caused by a defective catalytic converter, but I mean a second O2 sensor signal should be pretty consistent, okay, especially on the conventional narrow band O2 sensor. But this one is oscillating too much, so I'm pretty sure this is just being caused by a bad O2 sensor. We're gonna try to drive this O2 sensor lean and rich, and then we're gonna see how fast it's gonna react to the oxygen content in the exhaust stream. So now let's focus on these fuel trim numbers first. So I'm gonna increase the engine RPMs. So let's watch these numbers. So I'm increasing the RPM. I'm gonna increase up to 3,000. So as you can see, the engine RPMs is at about 3 grand, but our short-term fuel trim numbers are still pegged up. Okay, we still have 23%, 22% on the short term, and 28% on the long term. Okay, so I'm gonna let off. Let's see what happens. so we should have a rich signal over here, a rich signal that should actually stay for a little long. So this O2 sensor over here is bad, and these numbers, these fuel trim numbers, since they are not changing when I increase the engine RPMs, so this tells me that we don't have a vacuum leak. We most likely have a dirty mass airflow sensor. Okay, so I'm gonna start with the mass airflow sensor. We're gonna check our mass airflow sensor, because if we have a mass airflow sensor that's sending a skewed signal to the computer, it's gonna cause these fuel trim numbers to read positive, high positives, no matter how high the engine speed is. Okay, so now let's drive this O2 sensor lean. So I'm gonna pump the brakes. So I'm pumping the brakes here. Let's see if we can drive this O2 sensor lean. As you can see, I'm pumping this. As I'm pumping, I mean, we're definitely driving this engine lean because our short-term numbers are getting higher. Okay, but if this sensor was working fine, we should see a flat line down here. All right guys, so I'm gonna let off. So we have two problems here. So now what I'm gonna do is I'm gonna go under the hood. I'm gonna start by checking this mass airflow sensor first. Okay, since we have high short-term and long-term fuel trim numbers at idle and at high RPMs, we're gonna check our mass airflow sensor. If our mass airflow sensor is not dirty, the next thing we're gonna check will be fuel pressure. Okay, so let's go under the hood and check the mass airflow sensor, and after that we're gonna check this O2 sensor. We're gonna check the wiring. If the wiring is good, we will replace this second O2 sensor as well. So now I'm gonna turn off the engine. Let's go under the hood and check this mass airflow sensor. Our mass airflow sensor lives down here. We're gonna remove this, the top of this air filter box, so we can remove our mass airflow sensor. Oh wow! Guess what I just found. So here's our mass airflow sensor. Do you guys see this? So this air inlet dark is torn. So this is what's causing our fuel trim numbers to be high, because we have a leak right here. So this is the problem, guys. This is what's causing the lean code. Okay, so I'm still gonna remove this air filter box so we can check this mass airflow sensor. We're still gonna check it to make sure it's clean. So I'm gonna put you guys over here, and then I'm gonna remove this air filter box. So let's remove this top part of the air filter box. All right, so we're gonna remove this top piece of the air filter box. Have to remove the whole air filter box so we can get this mass airflow sensor removed. Alright, so here comes the air filter box, and our mass airflow sensor is right there. So I'm gonna get this out of the way. Alright, so we got our air filter box out of the way. So here's the problem, guys. You see this? So we're gonna have to remove this boot. Okay, so our air leak was right here. So air was going through this and inside the intake. All right, so I'm gonna remove this mass airflow sensor from the air filter box. Let's look at it and see if it's dirty. If it is, we're gonna clean it. I'm gonna clean the mass airflow sensor. I'm gonna order a new boot, okay, this Air Dark. I'm gonna get this ordered, and I'm also gonna order the O2 sensor. But before we replace the O2 sensor, we're gonna check the wiring first, okay? So I'm gonna get this out of the box, out of this air filter box, and then I'll bring you guys back up. So the mass airflow sensor is not really dirty. I don't know if you can tell, the resistors in the sensor don't look too dirty. So I'm gonna grab some brake clean so we can clean this off. So we're gonna use some brake clean and clean off this mass airflow sensor. Alright, so I'm gonna let it dry out and then we're gonna install it back up. Alright, so as we're waiting for the mass airflow sensor to dry, I'm gonna remove this boot over here that's torn. So this boot connects to the throttle. So there is a clamp over here that I have to undo. Alright, so here comes the boot. Okay, so I'm gonna get this out of the way. Once I get the new one from the parts store, I'll bring you guys back up so we can install it. So right here, guys, this is the source of the lean code. Okay, so I received the new boot, the air intake hose from Napa. So here is the part number for it. So I'm gonna get it out of the box. So here is the new one versus the old one. So right here. Okay, so we're gonna install this. So they both look identical, so we are good to go. So now I'm gonna install this one. Alright, so we got the air tube installed. This mass airflow sensor is dried up. Alright, so the mass airflow sensor is gonna go back this way. I'm gonna put it back on the air filter housing here. Chris, can you give me that air filter in there, please? Alright, so I also decided to go ahead and replace the air filter while I'm here. So as you can see, look at the air filter, guys. The air filter is completely dirty. Okay, do you see how your filter looks? So I mean, with those fuel trim numbers we had, I figured, you know, it would be a good idea to go ahead and replace the filter. But look at this. So once we get this filter installed, this car will probably, this engine will be saying thank you. I mean, if it could talk. So you guys saw how dirty this air filter was, so we're gonna throw that in the trash. We're gonna install the new air filter. We're gonna close this air filter box. So now we're gonna reinstall it. So I'm gonna go this way. Alright guys, so we got everything back together. This side is good to go. So since I already got the O2 sensor, I'm gonna lift the vehicle so we can do our test at the O2 sensor wiring. We're just not gonna replace the sensor. We're gonna check the wiring first. After making sure the wiring is good, since the second O2 sensor was responding slowly, we're gonna replace the sensor after checking the wiring. And after we do that, we're gonna erase the codes and look at the data afterwards. After we look at the data, I'm pretty sure our fuel trim numbers will get better. And after that, we're gonna end this video. So now I'm gonna lift up the vehicle so we can back probe the O2 sensor electrical connector. Alright guys, so we are here under the vehicle. Here is our second O2 sensor, and the connector for the O2 sensor is right there. So now, before we replace this sensor, we're gonna check the wiring of the sensor first, okay? So I'm gonna back probe all the wires at the sensor connector, and then we're gonna start the engine and watch the voltages on the lab scope screen. So I'm gonna back probe all these wires and then I'll bring you guys back up. So I back probed all the 4 wires at the O2 sensor electrical connector, and we have our ground over there on one of the bolts of the transmission. Okay, so we are all hooked up and ready to go. So now let's look at our lab scope. So we're gonna get our lab scope set up. So let's go to scope multimeter. So we're gonna turn on all our 4 channels. We're gonna be on the 20 volt scale on all of them, and we can adjust these voltages as we go. Okay, so this is good for now. All right, so Chris, can you turn the key on, please? So I have Chris inside the vehicle. So he got the key on. Okay. So right now we have 12 volts on the yellow trace and 12 volts on the red trace, and we have 1.49 volts on the green trace and 2.51 volts on the blue trace. All right, so go ahead and start it. So right there, this is our hero control. Okay, so we have voltage, we have our hero control. So the wiring is good, the problem is just the sensor. Okay, since the sensor is responding slowly, so we're just gonna go ahead and replace this sensor, and as we do that, this problem will be fixed. Okay, so all these wires are coming from the computer, I mean, except this voltage supply wire. I believe this voltage supply wire is coming, I mean, this voltage is coming from a fuse, maybe somewhere under the hood. I didn't look at the wiring diagram to know how this O2 sensor is wired, but I'm pretty sure the other wires are coming from the computer, okay? And since we have voltage on pretty much all these wires, any voltage that's on this wire, okay, anything below system voltage will most likely come from the computer, okay? If it doesn't come from the computer, especially these 12 volts, if this 12 volts is not coming from the computer, it's most likely coming from a fuse under the hood or inside the fuse box in the vehicle. Okay, so the wiring is good, so you can go ahead and turn it off, Chris. Okay, so turn the key back on. Okay, so as you can see, start it one more time. So right there we have our control. This is the hero control right here. Okay, if we increase our time base, we'll see it even more. Okay, okay, so our O2 sensor here is being controlled. We have voltage, so we're good to go. So now I'm gonna have Chris turn off the vehicle so we can replace this sensor. So Chris, go ahead and turn off the vehicle. Okay, we're good. All right, so the wiring is good. I'm going to disconnect all these test leads. We're gonna disconnect the sensor. So I'm gonna grab a wrench so we can undo this sensor. So here comes our O2 sensor. So right here, guys. Okay, so we got the O2 sensor removed. This is the second O2 sensor. So we're gonna get it out of the way. So here is the new O2 sensor. This is the part number right here. So let's install it. It's gonna go right over here. All right, so we tightened the new O2 sensor. So now we're gonna reconnect it. All right, so we got the new O2 sensor installed and the wiring connected. So we're good. All right. So go ahead and start it, Chris. All right, perfect. So turn it off. All right, so now I'm gonna lower the vehicle. We're gonna go back inside the car and erase the trouble codes. Then we're gonna watch our fuel trim numbers. If our numbers are good, we're gonna erase the codes and then we should be good to go. So now I'm gonna lower the vehicle. We are back in the vehicle. I'm gonna turn the key on. So we're gonna verify our repair before we wrap up this video. So let's go back to our OBD side of the tool, I mean the generic side of the tool. So we're gonna look at the data. I just want to see what fuel trim numbers we're gonna have now, and if our fuel trim numbers get better, this will confirm to me that this vehicle is fixed. Okay, these are the only data pins I want to look at. So now I'm gonna start the engine. So we are still in open loop. So we are in closed loop. So look at the numbers we have now. Okay, so at idle, on the short term we have 2.3%, and on the long term we have 0.0. So this is fixed, guys. And as you can see, the signal over here on the second O2 sensor actually looks a lot different from what we had before. Okay, so this is fixed, guys, as you can see. So total trims, so we have 4.7 on the short term and 0.0 on the long term. So this is fixed. So the problem was a torn air intake tube. Okay, so I'm gonna rev it up a little. All right, guys, so there's no questions about it. This is fixed. Okay, so our total trim is 5.5 on the short term. I mean, it dropped down to 4.7, so it's going between 4.7 and 5.5 on the short term, and we have 0.8 on the long term. Okay, so our total trim is about 7 or 8%, so that's good. Okay, so this is good, guys. I'm gonna leave it right over here. This is fixed. I don't have to test drive this. I mean, you guys saw that air inlet tube was completely torn. That was the cause of the lean code. Okay, so this is fixed, guys. I am going to back up a little. Okay, so I don't have to take this on a long test drive. But right there, as you can see, check engine light is still off. I mean, the check engine light was off to begin with. But right now, our fuel trim numbers are a lot better. Okay, look at that. So I feel comfortable with these numbers. If we back out and try to read the codes again, we won't have any codes in memory. Okay, so we're good to go. I'm gonna leave this right over here, guys. Let's look at the fuel trim numbers once again. So right there, short term 5.5, and long term we have 3.1. So that's it, guys. This is fixed. I'm gonna leave this right over here. Let me turn off the engine so we can wrap up this video. I hope you liked the video. If you did like the video, give it a thumbs up. If you didn't, give it a thumb down. But if you do, you gotta tell me why, so we can make better videos in the future. If you have any comments, questions, criticism, leave them in the comment box. Thanks for watching. See you next time.